In the last video, I created a generic team class and used it in the main method, declaring the type parameter for the teams I wanted to use. I first typed team with a baseball player in angle brackets to create two teams of baseball players. I also typed a team with football player in angle brackets, which supported a team of football players. Because of this, I couldn't add a baseball player to a football team. Java's compiler recognised this was a problem and gave us an error. That was a good thing. I'll add another team and a team member. This team will be Adelaide Storm, and I'll add the team member and Roberts and then print it out. In this case, I'm saying the type for our team member is just string. I don't use a player at all. This code compiles and runs. You can see our player, which is just a string value, and Roberts listed under the Adelaide Storm roster. The team class, the way we have it set up, can really work with any type at all. I'll add yet another team. The first was really an Australian volleyball team, so I'll create another volleyball team. I'll add a member, list the members, then score a game. This team will be Canberra Heat with team member B Black. I'll print that out and then I'll pass the two teams to the score result method along with their scores. And if I run that, you can see our methods work regardless of what type we use for the type parameter, with a couple of exceptions. You can't use a generic class with a primitive data type. Let me show you an example. You can see that gives an error. Luckily, we have autoboxing we can use to avoid a problem. I'll use the wrapper instead. I'll change it to integer in the angle brackets on the left. Okay, now let's just say we really don't want team to be used for any class under the sun. Instead, we want it to only work for things that implement the player interface. This requires one small change to the team class. After the generic type T, I'm going to type extends player, still in the angle brackets. Before I talk about this, let's see what it did to our code in the main method of the main class. In the two cases where I used team for string, and in the case of using integer, I'm now getting compiler errors. If I hover over string, I get the message that string is not within its bounds and that it should implement player. What does not within its bounds mean? On this slide, I'm showing the code for my class. T, the type parameter, is followed by the word extends and then the class player. This extends keyword doesn't have the same meaning as extends when it's used in a class declaration. This isn't saying our type T extends player, although it could. This is saying the parameterized type T has to be a player or a subtype of player. Player in this case could have been either a class or an interface. The syntax would be the same. This declaration establishes what is called an upper bound on the types that are allowed to be used with this class. This means that only subtypes of player or a player itself, if it were a class and not an interface, can be used with this class. In this case, this code doesn't care if player is an interface or a class. You use the extends keyword for either. There are good reasons for specifying an upper bound. We saw one already. To limit what types can be used by the generic class, but there's another advantage. First, I want to change my interface to have one abstract method, which I'll explain in a moment. String name. Remember that any method added without a method body is implicitly public and static on an interface. First of all, I know my records baseball player and football player both have an implicit name accessor method already, so this doesn't force a change to those records. They'll already have this method implemented on them. Going back to team, I want to revert that last change for a moment so that this class has no bound. Now I want to change the list team members code. Instead of using the default printout, I want to print each member on its own line. I'll delete that second statement and replace the code with the following. I'll use a for each statement to loop through every element and print each out on a new line. Note that here I am using T as the loop element type. For each element, I then print it out. Let's review if this works. The only difference is the members are printed on separate lines. But I really only want the player's name to be printed. If I go back to the generic team class, list team members method, I'll just use the name accessor method to do that. But now I've got a problem. This code doesn't like that method being called on the generic type T. Remember that at this point, generic type T can be anything under the sun, and as I've shown, it could be a string or an integer or anything. These types may not have a name method on them, and in fact they don't, so we can't try to use a method in our class that's not on java.lang.object. when you don't specify an upper bound, the upper bound is implicitly java.lang.object, meaning that's the only functionality that can be used on our type parameter without first casting. In this case, this is really too generic for our purposes. Leaving this method for a moment and going back to the class declaration, I want to get more specific, and again we'll add back the extends player. This lets me use the name method in list team members and the team class compiles. Going back to the main method, I have several errors. This is caused by the fact that I've said team can only be used for a type of player, not for any class, like string or integer. First, I'll comment out that last statement. I'll add a volleyball player record in this main.java source file. Record volleyball player with the name set up as the two records above. In a real application, your different player types would probably have different sets of fields. I'm keeping things simple. If all your classes really had the same set of fields and functionality, you probably would not want to differentiate them like we're doing. Rather, you would most likely find significant differences between a baseball player's attributes and a volleyball player's characteristics. I now want to use the volleyball player where I'm using strings for the generic team in my code. Next, I want to create actual volleyball players. I'll do that directly in the call to add team member, first for the Adelaide team, and N Roberts, whose position will be setter. Then for the Canberra team and B Black, an opposite. Let's run this code to see what happens. And that's good to see. The code is working and prints out the players' names. You can use the generic team with any type of class as long as it implements player. Let's review why you'd want to use this extends keyword with a type parameter, remembering that it's declaring an upper bound. There are two reasons to specify an upper bound. An upper bound permits access to the bounded type's functionality. An upper bound limits the kind of type parameters you can use when using a generic class. The type used must be equal to or a subtype of the bounded type. Before I bring this video to a close, I want to add another type to our generic class. You might remember that I said a second type parameter, by convention, should be SU or V. I'll use S because I don't want to confuse it with the static methods type parameter. This particular type is going to represent the city that the team is affiliated with, and I'll add an attribute called affiliation so that our team could be associated with different kinds of teams like city teams, country teams, or school teams. Private S affiliation. Next, I want to add a constructor to include this type. I'll add that after the one that's already there. I'll also add the code to print out the affiliation in the list team members method. I'll change println to print on the first statement and then add a second statement so these get printed on a single output line. Now this could be null if we don't pass it on the constructor, so I need to use a ternary operator to print it if it's not null. Depending on the value of affiliation, print either an empty string or the affiliation. So what is affiliation? Well, it could be anything. A string builder, an interface, or even a class or record. I will create a record called affiliation in this team.java source file. Record affiliation with the field's name type and country code, all strings. I'll override the toString method. I'll change this code to print out the fields. I could have made this a base or abstract class, but right now for simplicity, I'm just going to use this record, whether a team is affiliated with a city or a town or even a country. Getting back to the main method, you can see that this change has introduced quite a few compiler errors. This is because team expects two type parameters to be declared. To fix it, I'll do a global replace, replacing player right angle bracket with player comma affiliation then right angle bracket. I'll create an affiliation for the city of Philadelphia in the state of Pennsylvania in the US. I'm using var instead of the affiliation type just to save some screen space. var Philly equals new affiliation passing city, Philadelphia PA, and then US as arguments. I'll include that in the constructor for my Phillies team. Let's check if this works by running it. You can see the affiliation printed. Note that for this second type parameter, I didn't include an upper bound, so I could pass a simple string. or another instance of any class to another team. Let's do that for Adelaide Crows. City of Adelaide, South Australia in Australia. Running this again. You can see there is an affiliation for the Adelaide Crows now, even though I passed a string. There will be times when you want upper bounds and other times when you don't, as I've shown here. I want to encourage you to review what we've covered so far and get very familiar with what was done. I haven't covered multiple types in the upper bounds declaration or using lower bounds and working with overridden methods with these more complex bounded types. For the most part, you're far more likely to be using classes with type parameters than venturing into the complexities I've just mentioned. I'll be coming back to a couple more of these points on using generics a bit later, but first I want to challenge you on the topics we've covered so far with generics. In the next video, I'll give you a challenge, and then after that I'll go through some additional points about using generics.